And thanks everyone for joining in the evening on a quarantine day. And excuse my grooming because of the quarantine and lockdown in India. Let's start talking about fight complexity with functional programming today. Uh, so my name, I'm Gopal, and I work with Salesforce as a senior software engineer. This is my Twitter handle, so you might always DM me if you have any doubts on this talk. And my blog post or fullstack.github.io, where there is an entire blog post on this particular talk. So if you want to connect dots after this talk, you can go back and refer that blog as well. Great. Let's start our talk with a very famous statement from a manager, not my manager, though. If he watches the recording, you're not. You're awesome. So normally managers kind of, I would say, are against FP, mostly dev leads and managers. Whenever someone tries to introduce FP into the code base, they would kind of shun away, saying FP might add more complexity. So they say FP is cool because it's complex enough to make devs feel like they are doing something smart. So surely that's not the reason why we are learning FP today. Of course, FP is cool, but uh, this is not complex. We're going to see how FP is going to fight complexity rather than being complex. So that's it. Today, the talk would be based on a real world example that is currently running in production in our product. And so all the design decisions that we're going to discuss today have actually happened in real, and then they're all being implemented and then are running successfully for the past 2 years, couple of years. And if you have a similar problem, you can as well do that in your product or code base. So that's what I want to have you as a takeaway for this talk. That said, let's start our talk with something pretty serious. We just talked about the wars, developer holy wars we keep having in our teams on a day-to-day basis, right? So the first one in my list is Mac versus Linux. So I see this talk, at least in our floor, a lot, where few people use Macs and few use Linux. And people who use Linux kind of brag themselves saying they use the most powerful system. Well, I think I'm good with Mac because it's more stable and just make me focus on what I'm developing. Then comes the most famous these days, ID light versus dark theme. I don't remember having dark themes while I started coding, but these days this conflict has really become popular, going all over Twitter and Reddit everywhere, and keeps surfacing whenever a new theme is introduced. And programmers keep asking, "Does it come in dark? Does this ID come in dark?" So that's a very popular conflict. And another popular conflict, of course, is Eclipse versus IntelliJ. Eclipse is great. Eclipse is great because it's free. But then because we're in a Kotlin conference, I think I can be a bit biased towards IntelliJ here. I think we all agree. So I'm going to use IntelliJ, of course, in this talk. Uh, so let's move forward. Why am I saying all this? These are all some serious wars that we keep having on a day-to-day basis. What about this? OOP versus FP. So I hope at least some of you, whoever has seen FP or tried to introduce FP or worked with FP, would have seen this conflict. But I had this conflict too when I started learning about FP. How is it different from OOP? What makes FP better than OOP or OOP better than FP? Somehow I kind of searched everywhere, but I could not draw a perfect line between OOPs and FP and how to really see them as different things. There might be a reason for that. How do you define a paradigm? A paradigm can be defined with all the principles that are predominant in that paradigm. With OOPS, we have solid principles defined by Uncle Bob, and FP has principles like immutability, referential transparency, putting side effects at the boundaries, etc. OOP principles mostly talk about polymorphism and how a class or object should be structured, how inheritance, polymorphism, etc. While FP principles mostly talk about the discipline or how a function should be written and how things should be done in place. Like, for example, you're not supposed to do a DB call in the middle of a domain function. So these are all different things. I don't see why can't they be used together. Right, that was my first question about when I asked what is the difference between OOP and FP. But in the end, now that I have used both, I can realize that I can surely say they both can be happily used together. There is no contradiction between them. But that's it. Today, we can't talk about any of those FP principles because of the limited time. And even though if I go about talking about the definitions of what is immutability, what is differential transparency, etc., it isn't worth your time because you can always find them on various blog posts, so on books, etc. So what I thought is, let me use this time to show you or demo you how FP has made me a productive developer. At the same time, how it can be put to a real world problem and solved so that we can correlate while we see such patterns elsewhere. I feel that's a good use of our time instead of going to the definitions. And if you have kind of are from Java background or just even in Kotlin, if you have experimented with optionals or optional is of course in Java or sequences, etc. A basic functional programming. If you have done that, you should be perfectly able to follow this because there isn't really anything advanced going on. This is totally a basic plus a level of talk. Plus, I'm going to use this phrase a lot during this talk that please go back and refer because I want to cover as many concepts as possible within the context of this talk. Of course, giving you some appropriate pointers to go back and connect all the dots or expand your knowledge of whatever we have learned today so that we can kind of go fast at the same time, cover a lot of things. Awesome. And of course, the code. This is totally a demo-driven talk. And if you're like me, who feel stressful to see code while the talk is going on, really don't stress yourself. Like I said, I'm going to share everything, and I'm going to explain what the code is doing. You don't have to follow line by line; just kind of skim through it, and then we're going to see some awesome code examples today. Great. So let's start with another war, imperative versus declarative, and this is predominant in this in the zone, at least in Kotlin these days. And if you see from the figure, there's a Kotlin developer. Who is a Kotlin developer? A Kotlin developer is a guy who has just recently migrated from Java to Kotlin, and is totally confused which style to use because he sees compared to Java, there is a lot of tool set, functional tool set in Kotlin, and this guy is totally confused. How am I supposed to use all of them? And mostly he kind of tries to replicate whatever imperative style he has learned in Java in Kotlin, and I call him a Kotlin developer. Let's try to help this guy in finding out which style to use or which style fits what. Let's move ahead. What is an imperative style? Let's start with an analogy. Imagine you have a lot of puzzle pieces, Lego pieces, and then you have an instruction set here, how to fit those pieces together, right? So this is what I call imperative code. It's like you are giving to the computer the puzzles, the box of puzzles, as well as the instruction set separately so that computer will go through the instruction set and then fit all those puzzles together and then kind of run the code. Imagine fitting all the puzzles, you get the pipeline of your code, and then you can kind of run it. Let's see that with a real world coding example. Let's start to do some team building activity. Of course, we're all quarantined, we all miss our teams, but let's try to do some kind of a team building activity which kind of improves our mood. So the activity here is, are we gonna give all the names of your team? You can imagine your own teammates' names, and you have to concatenate all the names, taking the last name out of the each name, and then need to prepare a string like this, wherein there is a delimiter at the end, in the middle, between each and every last name. Right? I hope you understood the problem. Then, okay, the Kotlin developer starts coding, and then he comes up with this design. So in an imperative style, this code, wherein he's looping through all the team member names. He's extracting the last name. This is the extraction function. It is just a kind of taking the last word based on the space index. This works. And then he is kind of appending the delimiter and then returning the output. Great. And then he submits this for the code review. And the senior developer sees this and screams, man, what about all the corner cases? What corner cases can he get? See, this guy is using Kotlin. He's already handling all the nulls using this nullable types. Great. Had it been Java, he had to do all the null checks. But what about, the team is null? Or what about if the name is empty? What about there are more than one space? What about that trailing spaces? A lot of edge conditions, right? Okay, this guy goes back, thinks pretty seriously, and comes up with a patch. So now this guy is dealing with nullable, if the team is null, he's taking a nullable now, again, of course, a clever move. And then he's checking if the team member is null, and then he's checking if there are trailing spaces, etc., etc. And then he proudly pushes the code review again. Now, again, the senior developer gets frustrated and did you even test this code? Why? Because the moment he runs it, this is the output he gets. He has an extra delimiter at the end. This guy has kind of overlooked this particular edge case. Of course, it's evident he doesn't write unit tests. So let's go ahead and see what the Kotlin developer has done to deal with this. Okay, he thought again and came up with this another patch wherein he has a flag which checks if this is first, is last, kind of all that stuff. And then he would skip the delimiter if this is the first. So this code works in the end. He's happy. But the senior developer who sees this code sees the agile hotch, which is on the right side. So for me, I feel this is like a patched art form. So whenever you're trying to patch things, be it art or writing, it kind of loses its meaning of what it tries to convey, right? In this particular example, of course, he got it right, but what he's trying to do is totally lost in the details. He's totally, I mean, he might understand that, or he might himself might not understand after some time. But for a different developer who's reading this code, he really has to spend some good amount of time to understand what's going on there, because these are all puzzle pieces loosely coupled. They're not kind of tightly coupled. And he has the instructions that, hey, do this first, do this next, do this next. This is imperative style, and this is how it feels. Let's imagine this Kotlin developer is born in a parallel universe as a declarative coder, and then he's given the same problem. This is how he starts. Now, if you see the right side, this is a similar part of how his first stage one of the coding of imperative looks like. Now, on the right side, he starts with using a sequence, and then he kind of uses maps and join string. I'm not going to go in depth of what does this map do and what join to string do. These are all kind of a lot of documentation available for these APIs. But for now, all you have to understand is now he's kind of making a pipeline of things in a more tightly coupled way. Now they're not loosely coupled lines. They kind of join one to another. So the code, the state in the code is actually flows step by step, like on a staircase. And from this, let's say he kind of realized a lot of corner cases. How would he patch or how would he extend this declarative code? As simple as this. See how compared to imperative code, this is so concise. At the same time, talks to you what it does. By the way, I am taking nullable as a parameter, and this is only for the sake of example. I wouldn't recommend that doing in real world examples. If you really have a function which should take a nullable type, always have another different function, overloaded function, which doesn't take a parameter and then do what you require to do. So this is only for the example's sake. Imagine in this particular case, all these checks happen to be simple expressions. And as we discussed, this code is declarative. Declarative is saying, hey, I'm doing this, doing that, and doing this. And like I said, I have used an empty sequence in case team is null, but depends on your taste. You can put question marks everywhere. It still is a valid style in Kotlin, but I don't want to kind of pollute the code. So I just did this. So in case of team is empty, it returns an empty sequence, and none of these operations would be executed because the sequence is itself empty. So this code works as well, and see the compression difference step by step how we were able to achieve this code. And this null, of course, check is replaced with this nullable type, and then all this null checks and trimming and stuff is are replaced by this expressive statements which are filtering for null and mapping, and of course, I'm sending it to a map function which does a trimming, and then I'm again filtering for non-empty strings and all that stuff, which is very, very readable. It reads like an English sentence, right? And all this junk here, a lot of junk, I really have to spend time to understand what goes on here, is replaced by these two beautiful statements. That's all. So we saw what imperative code is. Now declarative code is like this, where the mental model is already made up. All the pieces are fit together in your ID canvas itself, and then you send it to the computer. Of course, computer, it doesn't make any difference. It only runs bytecode. But for a developer who reads your code, it doesn't have to kind of read the instructions and make a mental model. It's already there on IDE so that he doesn't have to, go through a lot of cognitive load. Awesome. So, so Kotlin just recently is in this race of languages, but we know Java for so long. It's kind of it started when most of us were in school, and people are still using it. And Kotlin is just new, but then it has a lot of functional set, and it is more advanced than Java. Why? Why is that more modern languages are running towards functional tool set, and old languages are trying to, catch up with these modern languages? And we have seen what this is, what imperative versus declarative is. But what I've displayed you is a different style of writing. But is it all just about style, or is there anything important? Let's see. Let's kind of give a wrinkle to a problem and then see how our imperative and declarative styles kind of handle this. So we're gonna do whatever we have done before in parallel now. Concatenate all the names in parallel. Imagine you have a huge set of names, and you kind of want to do divide, conquer, like using fork, join, pull, and other things, and do things in parallel. So how to do this in parallel? Of course, I am going to share you the implementations that I've used to make this imperative code parallel by using thread pools, fork join pools, and core routines as well. For the sake of time, I'm not jumping into it. Also, not to distract you with all those details. But believe me, it's not simple. It's not. It looks ugly, and it looks really scary as well because there are a lot of things going on, and probably as a junior developer, I would have been proud to write code like that, but now I'll be really scary to push something like that to production because I don't know what kind of deadlock or what kind of scenarios I might have missed. Uh, the reason why this particular code is not able to scale or not able to extend itself to deal with a simple requirement changes, it has two things, how to do's and what to do's. The looping through the list is how to do. Aggregating the results is a how to do. And what to do's are validating the names, extracting the last name. Validating for is not empty, has filing spaces, etc. So if you see that there's a distinction between the tasks this program has to do. But the problem is the imperative code has mixed all four together. Now that one of the requirements, which is looping through the list, has and aggregating, of course, how to do has changed, which needs to be done in parallel, the entire code has to be rewritten. And now it's totally shadowed. Whatever the core logic is shadowed behind all the details about multi-threading and other things. But how can we do the declarative code? How can we extend that to parallel? As simple as this, right? All you need is just change this sequence to a parallel stream, and everything looks the same, almost the same, because few function names might change because all these are extension functions on stream, parallel stream. But then the code structure remains the same. It doesn't have to change a bit. And even for a developer who is reading and for someone who is testing who has written unit tests for this, it's a breeze, just a simple line change. And then even the code reviewer doesn't have to stress himself. Why is this? What made this parallel stream better? I mean, of course, we saw what happened, but then why? The reason is the core context philosophy. The declarative code has followed this, but the imperative code hasn't. What is this core context philosophy? You can label this, of course, to FP if required, but this is an awesome software principle which should be followed across, which says that you should be coding to abstractions and not concrete types. Now that we have stuck to a sequence, which is an abstraction, we were able to simply switch that sequence to something else, and then everything runs as expected. So the context is switched, but the core logic remains the same. So you can essentially do things differently without doing different things, right? This is a very important philosophy which we're going to use in our talk to solve a problem. So let's move on. So we're almost halfway through our talk, and I've got an interval bank for you. We Indian moviegoers love interval banks, of course. So the sequence that you have been using till now is a monad. How many of you have heard about monads before? Of course, I know we are in a virtual talk. So I hope most of you might have heard about it. If you just want to get into functional programming, this is one term that haunts you at the start so that you're scared and would even go towards monads, so go towards functional programming. But monad is not as scary as it is named after. You're going to see that. If you ask me what a monad is just a design pattern. Monad is just a design pattern. And there's even a joke about it saying, if you understand monad once, you kind of lose the ability to explain them to others. By this guy called Douglas Crockford. But I'm going to break that curse today, try to explain you some monads. By the way, this was me trying to understand monads in my initial days, going through all those blog posts, books, etc. I couldn't make up anything out of it. Like they say, monad is a monad in the category of ender functors. And it didn't make any sense. It felt like a Harry Potter spell. But it turns out, once I kind of have gone through certain blog posts and written monads with my own hands, it's not at all scary. It's pretty evident. It's just named in a scary way. And by the way, for this talk, I'm going to refer to functors, monads, applicatives as monads instead of distinct having a. They are of course distinct, and we already talked about this in our previous talk in Hyderabad in template-oriented programming part 1. So you can either refer that, or there's a great article about it called Kotlin functors, applicatives, and monads in pictures by this guy, which I would really recommend. It's a 3-part blog post. You can go through it. Like I said, I'm going to refer to that as monads, and we're not going to jump into understanding how to write monads, because unless you're a library developer, you don't really need that. Writing monads includes some monad laws and stuff, but we're going to see how we can apply monads in real world and how we use them rather than what they are. So I'm going to use this monad throughout our talk, a very popular monad called either monad, and Kotlin doesn't have it out of the box, so I'll be using this either from Arrow. Arrow is an awesome library. We already talked about this. You should really go and explore. And either is a really simple type. Sorry, excuse me. And either is more of a sum type. If you have ever heard about algebraic data types, I don't want to really scare you with more functional, what do you call it, glossary. But then sum type is as simple as enum. So when you take an enum, it's always one value or the other. It's never both, right? Either is similar. So it's either left or right, but never both. So this property we're going to use to represent our valid and invalid things. We're going to see jump into the details more. So on the right side, we're going to put a valid object. And the left side, you're going to put an invalid object. Whenever you see this alien next, you just relate that to as a validation failure. So that's the monad we're going to use today. So, but what is this monad? Let's try to understand that through a crash course. So imagine you have a +3 function and you have a value. And traditionally, what you would do if you want to add +3 to that value, you'd pass that value to a function, right? And you get back the result. But if you have this value inside a monad, you would apply a function rather than passing this value to the monad. The function is passed in the value. It's the other way around. So if you just follow this cartoon, it's like you have a 2 inside a monad box, and then you have a +3 function. So what happens? You apply that +3 on 2 and put back the result in the box. This is how it's done in the code. So we have a either right, which is equivalent to this, and you have a map where you pass the function as a value, and then fold is a ternary operator wherein it takes in 2 functions, one for left and one for right, and based on what state either is, one of these functions would be triggered. So because now this is in right state, this function would be triggered, and you would get back a 5. So I hope you have followed. If you have any doubts, you may interrupt me now, so that because we're gonna go a bit more advanced, so that none of you are left out. Okay, cool. Moving on. So if you have sequence, this is as similar as we have seen before. It's just applying this function on each and every value. one after the other. So if you have a sequence of 246 and you have a function plus 3, you would be like getting a result of 579. As simple as that. And sequence is a monad, as we discussed before. This is as simple as it can get. Monad is nothing to be scared about. And what about when the monad is on left state? Why do we even have that state? The reason why we have is, now if you see in this particular example, the result is unit. Why? Why? Because at the moment this is in left, which means it's in the right state, none of the functions that you pass would be executed. So this plus 3 would simply be ignored because it's in the left state. In the fold, this guy would be triggered, which kind of returns a unit. So unlike before, we get a unit instead of 5 or 2, whatever. Great. So this can be used. This particular property is very useful when you have nested operations. Let's say I have to do +1 to +2 to +3. So traditionally, I would do this, right? And even in maths, you do f of g of h of x or something. But when you have them in either, you can do this linear transformation, you can say, wherein you do a +1, then a +2 out, and the output of that would be given to +3, and so on. And this is how it looks like if you kind of visualize it. And what happens if the box turns red in the middle like this? So all the subsequent operations would be ignored, like we have seen before, right? That's a beautiful property. You can call it fail fast, and which is gonna really get handy as we solve our problem. Yeah. So great. We have talked a lot of theory, and I've been saying a real world problem a lot of times. But where is the problem? We just got into it. Our monads used in enterprise software, right? If it's just for toy projects, you wouldn't be. I wouldn't be delivering this talk, or you wouldn't be listening to it. So we're gonna see how monads are used in enterprise software and real world applications. By the way, this is how our teammates used to react when we talk about monads. We got really cult following in our team when it comes to monads, because when we started discussing about it, we haven't, of course, there is no code base in entire Salesforce which used it directly in the sense. So we were kind of scared. Should we use it, or are we going to get trapped into some complex scenarios? So we did a lot of brainstorming. In the end, people were frustrated like this whenever someone says monad. But in the end, of course, we all thought it would be the best fit for our problem, and went ahead, and it is successfully running in production now. And coming to what our product, I'm just going to give a brief introduction to our problem, because that kind of helps you understand why we are doing it. That said, this is totally agnostic of what we are doing. We can apply this to any REST services if you have one. Uh, uh, be it backend or Android, whatever, be it the client side or the backend, you would be having some array of services which take in a JSON payload, and then you would have to validate it. This is pretty common, ubiquitous, both on client and server side. I'm just taking a server side example, but it can be applied to client side. And we have kind of REST APIs, which we call authorization, refund, payment, etc. They're pretty colloquial terms. We are a payments platform, of course, and we stand between, let's say, your pay now button and the one which deducts your money. And our payload looks very intuitive and understandable, wherein we take kind of amount, and then we would take a gateway ID with which you should process, and we take account ID, which account you are, and all the stuff, and all the card details, of course. So this is a sample payload that for one of the services called authorization. And this particular payload will get converted or marshaled into a POJO, which should be validated before we detect your money. So because this is money related, this is very crucial. We have to have a lot of validations for that. But for the sake of this talk, let's just focus on three kinds of validations. A simple data validations, wherein, let's say, amount is a integer, right? All it needs is a simple validation, like it is not negative, or it's not some $1 billion. There should be a limit, the upper and down limit. And effectful validation. So account ID is something that resides on a DB, and you can't just pass 1, 2, 3, 4. So I have to validate your account doing a DB operation. So that's why I call it an effectful validation. And then a nested validation. So if you see, this payment method is a nested object inside the parent object. And the best part or the worst part, you can say, is this payment method is used as is in a different REST service as well. Which means, let's say, take the example of refund or capture. which also has the same payment method object inside it. So why is this important? I don't want to rewrite all the validations for that, for the other service as well when I have validations here. So I want to share them. We're going to get into the requirements now. So of course, again, one more thing is these things come in batches. So we have list of such JSON objects. So this is a batch API, and that really gets tricky when it becomes a batch. We're going to see all of that going forward. So we had to build a batch validation framework to validate that. I hope you all got some context of what our problem is, and I'm really sure this problem is ubiquitous in across in any company or any product. You got to whenever you have a JSON payload or a POJO that you have to validate, right? But this is scary, and just for the sake of this talk, let's replace this POJOs with X, just to make this more funny and more understandable, rather than kind of getting into the details of a product. Like I said, this is not specific to a product; this is agnostic. So we're going to validate X, and X, of course, are valid and invalid X, which we have to provide results. So our framework requirements, as we discussed briefly before, is configure the order of validations. Now we discussed what kind of validations they are, but I have to configure them based on cheapest to fastest. So imagine amount data validation is pretty simple. I want to put that first rather than doing a DB operation for account. Of course, that's pretty intuitive. And cross-share common and nested validations. We already discussed about payment method is common across various services. So I have to kind of plug those validations into the service rather than rewriting them again. Plus, let's say amount field is common across all the services. So I don't want to write the same validation again and again. I should be able to cross-share them. And fail fast on each sub request, pretty explanatory. Partial failures. This is the tricky part when it comes to batch validation. When you have a list of JSON objects, imagine this is a scenario. On a validation layer, you kind of said these two things are invalid. Okay, you went ahead, and your service layer somehow you're crossing the borders of layers now. Imagine, and service layer somehow has to know that these two things are invalid, and I shouldn't do any processing on them. And if I have more invalids or some kind of exceptions, I would also add them to invalids and then pass to some other layer. So and so on. And then because this is a batch, whenever I find the invalid, I can't right away send back an error response. I got to wait till the end, till the end of the use case, and then send an aggregated response in the end. Like all these aliens go back in a spaceship back to the customer. So that's what the problem. That's what the challenge is. You can't store in a temporary place because you're crossing borders. We'll see how we can handle that. And some framework meta requirements like we have a century of validations. So if you have just 5 to 10 validations, it doesn't matter. You can write in any way. When you have more than 100 validations spawned across various services, really gets difficult to manage writing using if-else conditions, etc. And unit testability is very, very important because validations will have a lot of corner cases. Most of them are data-driven. Most of them are some are effect-driven, and no compromise on performance. Of course, as the batch size increases, a performance would be kind of degraded if you do something wrong. So you got to have really have to have the eye on performance whenever you do some design, right? Like everything in the world or everything in our software industry, you don't get requirements on day one, right? Things are agile, we call it agile. So our requirements keep changing. That's how even that happened in our team as well. So on day one, we just had one egg and one validation. What I mean is we just had one service. We don't have batch. And our validations are very less when we actually started our product from scratch. So people were pretty happy. We just wrote a if-else condition and everybody is like celebrating. Okay, we got many X, which means RPM said we got to do a batch validation because a customer asked for it. We thought it's okay. We kind of loop everything and then do the stuff. We'll get the same results. People are still not so kind of pissed or not so scared. But the moment we got this requirement where we have many eggs and many validations, as our validations increased and as our services increased, it really got out of our hands. We could not handle with if-else conditions. But let's not see that. Let's see that with some code. Of course, I can't show you my production code. So I'll be showing some dummy code that I have written to simulate or emulate what really happens, which I'm going to share, of course. So let me start. I hope the font and everything works for everybody, is visible. People who are logged in from mobiles, I think
Gopal, can you make a little
you
bit bigger
might
font?
have to log in from. Sure, yeah.
Yeah,
Is it good? Okay,
yeah.
great.
Thank you.
So yeah, so let's talk about some operations that we're going to do as a part of validations, and then we're going to jump into validations. As we discussed, we have three kinds of validations, right? So I kind of simulated three different types of operations that we're going to perform on each type of field. So let's say you have simple operation, you have an egg, and all you have to do is a null check. So relate that to some amount validation that we have seen before. And you have some throwable operation. The reason why I named it throwable is if you are doing a DB operation, that's exception prone. You're supposed to handle an exception. So imagine this throws an exception, but this you don't have control over the exception. So it kind of based on some if else condition, it throws an exception. And then you have a nested operation, which works on a nested object. Now I'm trying to represent yolk as a nested object inside egg. I hope it's pretty intuitive for everybody. So that's a whenever you perform an operation on an egg, you have to perform on the egg as well as the yolk. So you first finish your parent operation and then operate on your yolk. Okay. Now we're going to see how our validations are performed. So I definitely need to increase font size for this because this really is something we're gonna see on a day-to-day in our code basis a lot, especially code written prior to Java 8 or something. And even these days, not many people are into Java 8. But if you're into Kotlin and if you're still writing this, you're a proper Kotlin developer. So what is this code doing? Let me briefly explain what this code is doing. But looking at it, it looks not really good. So what I have is I have a list of eggs. I have a carton, and then I in the end have to come up with what are the valid eggs, what are the invalid eggs. So the approach I took is I have a bad failure bucket map. So what does that mean? It kind of holds all the failures, all the IDs of eggs which are failed, and then I kind of am looping through using an iterator, and I'm performing an operation, sending each egg into that operation, and then I get back the result. Based on the result, I remove that egg because I don't want that egg to go into any other validation if this is invalid by this operation. And then I put that egg inside this map, right? That's as simple as what I'm doing, but then the code makes it look a lot more complex. And the moment I get throwable operations, I got to do try catch. And if it is nested object having nested exception, imagine how it kind of goes on. Even my monitor wouldn't fit if I keep having more and more such validations. This is totally not scalable, not extendable at all, because uh, imagine you have to shuffle your validations or add new validations or even unit test this particular function, but jumbo function. It's totally not realistic. But this is something we have seen a lot of people do in our product in other modules as well as in other systems as well, because this is the easiest thing or intuitive thing to do, easy to write, but very difficult to manage, very difficult to test. The reasons is, of course, the complexity. How do you measure complexity? Today, we're going to use something called cognitive complexity. This talk starts, even the abstract of this talk starts with metric-driven approach. So how do you measure complexity in a particular code? I have used a very popular tool called Sonar Cube. I hope most of you have heard about it, which measures two important metrics: cognitive complexity as well as cyclomatic complexity. Cyclomatic complexity is, of course, important, but that doesn't actually represent if the code is readable or not. I'll give you an example. If there's a switch case, what cognitive complexity does is it gives a +1 for each and every case, and it says if there are 4 cases, the complexity is 4. But in reality, it's pretty intuitive to read that code, even if there are 4 branches. So the cognitive complexity metric would say only one. So that's how a cognitive complexity is more reliable and best to measure complexity when it comes to readability. So I kind of have already measured the complexity using SonarQube. What I did is I'll just go to details very briefly. I'm using Gradle, of course, and then there is a plugin already for SonarQube plugin. This is all you need. And there's a Gradle task, Gradle SonarQube, and then you got to have a SonarQube running in your system. Okay, not console. Yeah. So you should be having the Sonar console running. So if you are building this in a CI system, you would have to install that on your CI. Now that I'm just showing you on a local system, you would have to have a Sonar running here. With this said, I just have to run this Gradle task, Gradle SonarQube, which I've already run and have the metrics ready. You're gonna go here, measure, and then you have complexity and cognitive complexity. Now I'm gonna show how the complexity of our, reload this. So I have this project. I go to measures, complexity, cognitive complexity. And then the code I've just shown you is inside here, app imperative. So if you see the numbers might look small because this is totally a code for demo. So I did not put a lot of code. Even for the small code, iterative validation. Yeah, even for a code like this, you get to see huge numbers, which is really wrong. Is there anything that we can kind of do? We can probably break this particular code into different functions. That's the first thing that comes to my mind. Let's see how that looks like. So what I'm doing here is I have shown you some operations. Now I just kind of put each and every operation inside their own function. Validate one, use call simple operation, and it gives you back the result, whatever it has given. And then also does this extra mutation, mutation filled code. Of course, we're going to talk about that. And then, of course, all the other operations are put inside their own functions. This is a bit more better. Let's see the complexity here. This is imperative validation 2. The complexity has more. One of the reasons is I've added more operations, but the actual reason is there is this guy sitting at the end. So this is the orchestrator of all these functions. So this guy is calling this each and every validation, getting back the result. And based on the result, it is either continuing or kind of failing fast. This I would call something an octopus orchestrator because it is doing a lot of things, kind of trying to orchestrate all the validations, looping and removing eggs, putting eggs back, all the stuff. And this is gonna again get converted into a giant monster. So we haven't achieved, what I'm trying to say is we haven't achieved anything by breaking these things into functions. So that didn't solve a problem because we still have this guy who orchestrates everything. And he's still the bottleneck to change the configuration or you can say add more new validations, etc. So what happened? We kind of are stuck with this chaotic code. So this is how egg is trying to escape all the validations. This is how debugging a code feels like. By the way, I loved playing this game as a kid. This is called Mario Hell Level or something. So how can we get rid of this chaos? So I hope you all have heard about this pattern chain of responsibility. And this is a very popular pattern when it comes to validations. So chain of responsibility is you have a chain of validations one after the other, and you kind of send this this object to be validated into one after the other. So we're going to see how we do it in a functional style. But before that, is FP a best fit to implement chain of responsibilities or to handle a scenario like this? Of course, we're in a functional programming talk. What else you expect me to say? So I can't like take your till here and say, I'm sorry if he's not a best fit and oops is a best fit, right? Yeah, I know it's a bad joke. I can't hear anyone laughing. Of course, the virtual talk, my jokes, I don't know if they're hitting or not. So if you see, this particular problem is a two-dimensional problem. So if you see validations are functions, we treated them as functions, of course, but the moment you see them as values, functions are values as well, you'll get a different perspective for the problem, right? This is just you have add two arrays and you just have to kind of make a matrix out of it, which is valid and which egg is valid across which validation. So that kind of totally turns the way you think about it. And why FP is appropriate for a problem like this? FP shines whenever there's a scenario wherein there are set of transformations or operations done on an object. In this particular scenario, we are not calling any functions on any object, right? What I mean is we're not calling any operations on eggs. Instead, eggs are being operated upon. So there's other way around. Eggs are being passed on to each and every validation. And the output of each validation happens to be input for the next one. That's what I call data transformation. That's why even FP is a best fit for domains like big data, reactive programming, etc., where you have a sequence of transformations to perform. Whenever you see that, next time you kind of have to identify that you have to use FP. Whenever you see a sequence of operations and you are struggling with writing nested else conditions. So we're gonna build something like this, an extensible machine, which has three parts, where you have validations, which are what to do's, and you have a configuration layer, which says which validation comes first and which comes next, and you have an execution layer, which runs all these validations based on the strategy you need. So the first thing I would do is make all the eggs immutable. This might not be the exact requirement for our design, but then the moment I make eggs immutable, it kind of removes a lot of cognitive load as a developer, as a debug code, because I know now that the state of my object never be changed. No one has changed it. So I kind of don't have to put a debug point thinking where this particular state of this object has changed. That removes a lot of cognitive complexity now. Now we are jumping into the phase where we're trying to remove cognitive complexity, right? So this is first step. And second step, if you think about our particular scenario, we have an heterogeneous data types in pipeline. What do you mean by that? What I mean by that is you have valid eggs and you have invalid eggs as well, which are of two different types. We don't care about invalid eggs. All we care about why the eggs are invalid. So we care about validation failures, right? If you see the code here, we go into validate one. Sorry. So here, this is a validation failure. So I'm concerned about, I don't put the egg inside it. I put the ID along with the validation failure here. So that's what I want to focus on. So there are two different types, and Java list kind of prohibits having two types within a list. So for that reason, we can kind of have to put them in monad boxes that we have discussed before, in either monad. So the moment you put them in the monad boxes and use left and right states to represent, now you will have eithers flowing in your pipeline, but you will also have two different data types to hold, right? I hope you got the point. So that does the trick. So we kind of put all our eggs into monad boxes. And the third step, we're going to standardize our validations. What I mean by that is, let's make all our validations talk the language of monad. So how can we do that? Let's see. So this is how our new validations look like. Now, I also want to put this side by side to our previous. So this is how our imperative validate one looked like. This is how our imperative new declarative validator looks like, wherein we kind of have used lambdas in place of imperative coding, and the lambdas also lambdas receive either as input, if you see here, and then they would perform operations using filter orders. These are operations similar to what we have seen on sequence before, and they also have the same intent. So what it does is it filters whenever this returns a false. So what it means is the operation said this egg is invalid. So I would put a validation failure in place of valid egg. So this turns into a left state if this validation fails. And then this input is pumped into the input of this. We're going to see how that pumping is done. But for now if this egg also receives a valid egg, which is of type either, and let's say if this is in the left state, none of these operations are performed on this. This is what we also discussed in the pictures that we have seen before. So don't focus on what is going on here. Just focus on the philosophy that I've just told, that none of these operations would be computed on this particular egg if this is in the left state. And similar philosophy applies to other validations as well, but we're going to see how we can orchestrate all of them. We just saw this explanation. So configure the order of validations. Now that's our first requirement. Now that we have validations as values, how can we configure them so that one comes after next? A simple ordered list, right? So imagine this is how you can represent a chain of validations, like as we discussed, a chain of responsibilities. So you have validation 1, 2, 3, one after the other. So that kind of puts validations in order. Now, if you see, this is totally decoupled from what validations are. Validations don't know, these guys don't know who comes first, who comes next. This layer actually does that part. You can imagine this is some kind of Spring config or whatever dependency injection that you use in your product. You can use that here, use that there. And what is the second requirement? Cross-share common and nested validations. So let's jump into one of the child validations which work on a yoke. So contrary to this guy takes in a validator. I'm not going to go into details of what this validator is. This is just a function. I just made a type alias so that it looks brief. So what this is in Kotlin, we have, of course, this function, first class function types. Had it been Java, I would use a function interface. Now, this function takes in an either and gives an either back. And the either has a failure on the left side and validate on the right side. And the output either would have a failure on the left side and, of course, valid on the right side. So that's it. So this is your child validation, right? So how are you going to kind of glue this child validations to this parent? We're going to do something called lifting. So this is, I've just shown you what the type alias is. So this operates on a validate T, right? Validate T is generic. So this is a parent validation because this parent validation has an egg validation. This is the signature of a parent validation. And this is how a child validation looks like, which operates on a child. This child T can be replaced with, just compare this and this. So we have a yoke. This is a child validation. You have a egg. This is a parent validation. So how can you combine both of them into one list? Again, these two are different data types, right? You do something called lifting. So lifting is like a functional programming terminology, is a concept. You can think of more of it like a wrapping. You wrap one function inside another. This is a bit more advanced. I don't want to really go into details, but then I just want to show how it is being done. So if you see here, in this egg validation, what I'm going to do is I have parent validation list, these are all validations which operate on egg, the parent. And then you have child validations. These are all validations which operate on yoke. Now you have to create a single chain wherein all nodes are of same type. So what you do is kind of take parent validation and lift all the child validations as in here. Like I said, if you go inside this function, you really see some scary generics. But then if you're interested, I would request you to just put a debug point and understand what's going on there. Because this is targeted for basic audience, I don't really want to get into the details of it. But if you really want to understand more, please DM me. I would be happy to help you. Great. So what happened is you actually got a uniform chain of validations in your bag. So what you're gonna do? Fail fast on each sub request. That's a strategy. Now you have your list of X, you have your chain of validations, and then the only missing piece is how you're gonna orchestrate all of them. We have seen our previous orchestration using if else, where this orchestrator is doing everything manually. It kind of checks the results and other things. But then we're gonna see something we can do pretty easily. Okay, so this is how we can start kind of having all these validations, orchestration of all these validations. Let me start with this. Okay, so again, a disclaimer, a little advanced. If you are really not following in this particular talk, go back and just refer the code and along with the recording. So all I'm trying to do is pump in. We have discussed before how to pump one result of one validation into another. So for that, what we're trying to do is here, gets uh, this guy gets a list of validation. This guy is a fail fast strategy, of course. And what he takes input as a list of validations, and then he would be operating on each and every validation. He would take an egg, and then he would be kind of calling all the functions one after the other. Let's see a test case which kind of makes use of this. So I have a list of eggs, and then I've taken that as a sequence. And then what I do is I do a map and apply all these validations on that. So what this particular guy is doing is turning all the chain of validations into one single big function. So which is using fold and all that stuff. I don't want to get into that, but fold is just simple. It just is an aggregation function that we have discussed in our previous talk. So what it does, I just focus on what it does. What it does is it takes a list of validation and it converts that into a giant validation function, which is kind of we map it on a particular egg, and then you get the results back. So what you get is the output would be a list of eithers. So you have pumped list of eggs list, and you got back list of eithers. And we have discussed before. We have monad boxes. We have put eggs put in monad boxes, right? So we have eithers which are kind of left on right state. So that means you got the results back. Now see how clean this approach is, so that you really don't have to bother about storing that in some temporary bad failure egg map. Now you get the results back, right? Awesome. So what's our next requirement? And by the way, we discussed about fold. I just want to just have a skim a slide about some operation that you can perform on a day-to-day basis, like this map, flat map filter. I really recommend you to go into exploring these API documentations. They're all present out of the box from the Kotlin library, Kotlin JDK 8 library or JDK library itself. And they really reduce your code to almost 4:1 ratio and kind of make them concise. And it also helps other developers who see your code to kind of read what is going on. The moment you understand what a fold is, what a reduce is, it's like shared patterns, shared vocabulary that you can share among your team. And the code review really becomes simple because I really don't have to go into a for loop and see what is going on there. And partial failures is a last requirement. And this is kind of tricky. Partial failures, as in we discussed before, since we have to pass these failures across the layers and then have to skip some bad eggs before in between. So the problem here is before we had to store in temporary place, and of course we can't pass a temporary bad egg failure map to a different layer. Now here I got a list of eithers. Now the moment I pass this list bag of valids and invalids to our next layer, which kind of operates on the same, so it's gonna ignore all the lefts and just operate on the rights because that's the property of either. So that's how we were able to achieve partial failures as well. and propagate those partial failures to the next layers. And scalability, of course. We can't finish a tech talk without a matrix meme. So imagine I have to do this in parallel. It's the same trick that we have done before. So instead of taking a list of eggs in a sequence, I can take a list of eggs as a parallel stream. So based on the maximum size, imagine you have a requirement if you have more than 10,000, you want to switch to parallel. And that strategy is taken care here without changing any of the code. So that's it. What about complexity? Okay, that's the title of the talk. If you see, this is imperative complexity I've shown before. I'm going to declarative one. And if you see, this is a file which I've been using to represent validations, and it's literally zero. Why? Why is it zero? Because now we don't have any branches like if-else branches, and all of the code is running linear. Let me show you the trick why it is being that's happening here. So I'm going into one of the validations, and I'm going into flat map of the source code of flat map. So if you see it carefully here, this guy has a simple one. And what it does is, if this is in the right state, the function you have passed would be applied, the same, that plus 3, if you remember that we have discussed before. And if it's on the left state, this is ignored, right? That this simple philosophy underneath, which is managing all the if-else conditions, is helping you to write linear code without any branches. So now the code is flowing linearly. For that reason, our cognitive complexity has become zero. If you see the code, I even added so many operations compared to what compared to our imperative, but our cognitive complexity is literally zero. So that's how you can kind of reduce complexity in a code basis by writing linear code. With that, I want to make a statement that FP is not complex, but it fights accidental complexity. And we just achieved minimum accidental complexity with the same time complexity. If you're wondering why I use railway oriented, this is a popular pattern called railway oriented programming by this guy Scott Blashin. It's coined by him, and there's a great blog post as well as talk by him. And you should be able to find it on Google. And really recommend to go through it because it's really an awesome talk. And it's done in F#, but you should be able to connect that to what is going on in Kotlin if you have followed this particular talk. So finally, great. We have turned our chaotic code into a linear code like this surfer. And these are the code examples. So if you can refer this recording if you want these links. I hope you'll also be getting it in the video description. And I want to just conclude this talk by this one particular paradox called the bluff paradox. If you see this doesn't say whether if you see this guy is functional programmer who is at the top, but this picture doesn't say that knowing functional programming makes you is anything superior or inferior, but just knowing it makes you a better developer, and we would know where to apply functional programming and where not to. It's not always a silver bullet that you can put everywhere that solves your problems. Sometimes you end up writing more complex code than required if you kind of go into using functional constructs. So you just have to make the decision, and the only way you can do that is to master both. And thank you so much. And I would love to hear some feedback. This is my personal email. And skadoosh, we can have won our war over functional programming. Sorry, complexity using functional programming.